Good evening, everyone. So, again, welcome you all to the today's Focus Weekly session dated 17th February 2025. The topics which we are going to discuss have been displayed on the screen. And as you know, these topics will be from the prelims as well as the mains perspective, depending on the topic. We have taken the important topics from the last week of Down to Earth, Monga Bay, Hindu, Indian Express, Yojana magazine. Those topics which we found relevant for the upcoming prelims examination as well as maybe in mains also. Okay. So the topics, as you can see, is in relation to the Teesta River, that is the mapping portion, because we know that every year you find some questions which are from the India's map, and that too mainly from the rivers and their tributaries. Then we have another topic, Glacial Lake Outburst Flood, GLOF. So this topic basically forms the part of disaster management as well as important geophysical phenomena. So this topic will be dealt from the mains perspective and is important in General Studies paper 1 as well as GS paper 3. Then we have loggerhead turtles, important species, very important species when it comes to the India's wildlife species and biodiversity. Then we'll see the difference between turtles and tortoise. So these two topics are interlinked with each other, and we shall be knowing that which are the important turtle species which are found in India. We will be doing loggerhead turtles in detail, and then we will see that what is a basic difference between turtles and tortoise. Okay, and then again from the mains perspective towards the end we will be having the topic of pollution, air pollution in North India. So generally the context of the topic is the Delhi air pollution, but Delhi being the capital territory, that's why it is so much in news. But otherwise, the entire North Indian belt experienced very severe air pollution. So we shall be discussing that what makes North India so unique that it experiences pollution. What are the anthropogenic factors and what are the natural factors? Okay. So these are the topics which we are going to discuss. Without wasting much time, let us begin with the first topic. So the topic is in relation to the Teesta Dam. And recently it has come in the newspaper in the context that recently the Environment and Forest Ministry has approved the proposal for the rebuilding of the Teesta 3 Dam. Now, if you remember last year, Teesta 3 Dam suffered significant losses because of the Glacial Lake outburst flood in the state of Sikkim, and the lake in news was the Lonak Lake. So South Lonak Lake, basically it underwent the Glacial Lake outburst flood, and that bursting of the South Lonak Lake critically damaged the Teesta 3 Dam. Okay, so in this very regard, we shall be discussing first few of the important key facts related to River Teesta and its tributaries, because again from the mapping section this topic becomes important in Indian geography part. So again, there are certain key facts related to River Teesta. Okay, so we all know that River Teesta is origin of the River Teesta is this So Lamo Lake. So word is basically a Tibetan language word which means lake. Okay, so you will hear a lot of lakes named as Pangong So, So Moriri. So TSO, So is basically lake in Tibetan language, and therefore the So Lamo is the point from where it is originating in the North Sikkim. Important thing is that this Teesta is an antecedent river. Okay, antecedent river means that the Teesta river was present before the uplifting of Himalayas. So antecedent river means those rivers which were present before the upliftment of the mountains, right? Antecedent rivers are those rivers which were present before the uplifting of the mountains. And here, because we are talking about Himalayas, so Teesta was present before the Himalayas. If any river is present before the rise of the mountains, those rivers are known as antecedent rivers. Okay. If we have to go by the basics, so antecedent, so you must have read about drainage systems and drainage patterns. In drainage systems, we have two types of systems. One are those rivers which follow the regional slope, and we call them as sequent system. Okay, those rivers which follow the regional slope are known as sequent system. And then there are other rivers which do not follow the regional slope, they make their own slope. They are known as insequent system. So antecedent rivers, because they are present before the mountains, So when the mountains will start rising, these rivers will try to maintain the level of their valley floor, and that is why they will cut it down vertically. So when vertical cutting will be dominant, so that is how they will try to maintain their own valley, their own slope, their own gradient, rather than conforming to the gradient of the mountain or the regional gradient. So that is why antecedent rivers are the example of insequent system, and that's why this Teesta river is antecedent and is insequent system. In antecedent river, we have learned that vertical cutting is the most dominant one, vertical down cutting. Okay, and from this, another concept is that if vertical down cutting is dominating, so that will lead to what? That will lead to formation of topographic discordance. So you can have some of the important landforms in antecedent river systems. And one of the most important landform in antecedent river systems is what? It is incised meanders. Right? So this is a chief characteristic of the antecedent river. So incised meanders will be there. River terraces will also be there. River terraces. And another important thing is that because we are saying that the river will be cutting down, so that means the erosion intensity of the river will be very high. If erosion intensity of the river is very high, that means what? A lot of sediments would be eroded, and that will be brought down by the rivers in the lower plains where they will be deposited. So those rivers which are antecedent in nature, because they have high erosive capacity, that river ultimately will lead to higher deposition also in the lower areas. So that means what? That river will bring flood in the low-lying areas. And that is why when Teesta rivers brings a lot of sediments with it and it merges with river Brahmaputra, which we know that cause flooding in the low-lying areas, and then there is a formation of braided channels and all those things. That becomes the part of the static topic. Okay. So I hope that we are aware about this system, that what is antecedent river system. And they are generally known to have very steep gradients also, because vertical cutting is dominant. If vertical cutting is dominant, so obviously the slopes of that particular area will be very steep, right? So the course is that it flows through the Sikkim and the West Bengal in India, and then it enters Bangladesh. Here it merges with Brahmaputra river, and that Brahmaputra river is known as Jamuna in Bangladesh. Important tributaries of river Teesta is Rangit, Lachung, Lachin, and Dikchu. But Rangit is the most important tributary because this is in newspaper many times. Okay, so you have to memorize at least this one name. Rangit is a tributary, and then it's up to you. If you can remember these names, it's fine. Okay, talking about the water dispute, so Teesta water dispute is between India and Bangladesh. There were some agreements related to the sharing of the river Teesta. Bangladesh was demanding 50%. We said that we need 55% in a particular season, that is between December and May. Okay, so that particular area, which is a lean season also. So river regime is not at its maxima during December and May. What do we mean by river regime? River regime is a seasonal fluctuations of the rivers. Okay. So for example, if we are talking about Himalayan rivers, so let's say Himalayan rivers basically will reach their maxima, that is the maximum discharge. So Himalayan rivers will reach their maxima when there will be glacial melting, that is during the summers, and then there will be a slight dip, and then again it will reach its maxima when the monsoon will come. So during summers, because of the glacial melting, okay, and then as soon as the monsoon strikes in, so because of the rainfall, there will be two maximas of the Himalayan rivers, right? So if this y-axis, if I write this y-axis as the discharge, so we can say that the discharge of the river volume will have two maximas. This is the time, this is season, two maximas in 1 year. This is showing you the river regime. But again, here we have discussed that it is during summers and then just 1 or 2 months later during monsoon, because there is a very small gap. Na? Summer comes in India in month of April and May, summer starts. And then up to mid June or July, the monsoon also reaches to Himalayas. Fine. So that is why you have two maxima points. But if you will see that this is the lean season, this is January and this is December. So January, December, January, February, March, this is generally the lean season in the river. So that is why in this particular season, the river volume is less, and that is why the downstream countries are more concerned that when there is a lean season, how will we get the water? So that was the agreement, but we all know that because of the internal factors, because of the political reasons, so this deal could not be carried out, and that is why the dispute is still remaining between India and Bangladesh for the sharing of river Teesta. Fine. So this is the static part about the river Teesta. So this was the geographical part. Now in this relation, we should understand that because the context of this news was the rebuilding of Teesta 3 dam, which we discussed that last year it suffered significant damages because of the glacial lake outburst flood, which lead us to the second important topic, that is GLOF. What do you mean by GLOF? So here this picture basically show you that what is a glacial lake outburst flood. Okay. So first imagine that in a particular area there is a glacier. Glacier is what? Glacier is a moving mass of ice. Okay. So till the point the gradient of the mountain is steep, the glaciers are able to move. They move with very low velocity, that we know, but still they are moving. As soon as the gradient will become relatively gentler, so their velocity will further reduce. A time may come when this glacier will be stagnant over here. So this stagnation can be because of the relative gentle gradient, as well as this stagnation or the accumulation of this glacier can be because of the blockage. So let's assume that there is some blockage which is not allowing the glacier to move further. How this blockage can be there? This blockage can be there because of the deposits known as the moraines. Moraines are what? Moraines are the sedimentary deposits which are brought down by the glaciers with them. So when the glaciers move, similar to the rivers, rivers also carry the sediments, glaciers also carry the sediments. When the glaciers move, they carry the sediments, and again, whenever there will be change in velocity, reduction of velocity, those sediments will be deposited. Same thing happens in rivers also. Fine. So what will happen, that there will be some deposits of these moraines on the banks of the glaciers. There can be deposits on the front end of the glaciers, and there can be moraine deposits underneath the glaciers also. So imagine it at 3D. So now can we say that if such deposits are taking place, so that deposit will obstruct the movement of glacier? Okay. Again, the analogy can be drawn from the rivers. So when the rivers reach in the senile stages, in the last stages of the river, where there is excessive deposition, that deposition of sediments obstruct the river flow, and that is how the river further change its course to bypass that obstruction. That is how the braided channels are formed in the later stages, old and senile stages of rivers. Similarly here also, because this obstruction is created, so the glaciers will remain stagnant. Now imagine that because when the summers will hit, or because of the climate change, the global warming, bottom line is when the temperature will rise, maybe because of seasonal change or maybe because of the long-term climate change. So whenever the temperature will rise, what will happen? The glacier which is present over there, it will start melting and the glacier will recede. But the glacial melt water will remain stationary over here, right? Rest of the glacier will recede. And this melt water is known as glacial lake, because this lake is formed out of glacier. So here you can see that this particular picture shows you the presence of glacial lake. This is a glacial lake. So from this point, can we understand that because we know that glacial lakes obviously will be formed in the higher reaches of mountains, it cannot be there in the peninsular area or the Gangetic Plains area. They have to be in the high reaches of mountains. So if, and that in India, that is Himalayas. So in Himalayas, you are having glacial lakes. We all know that Himalayas are tectonically unstable. We all know that Himalayas are having soft sedimentary rocks. We all know that Himalayas experience earthquakes, landslides, cloudbursts, etc. So let us imagine if any of these factors or a combination of these factors is hitting, let's say this is a mountain. Okay, here you are having a glacier. So in the upstream area, let's say there is a landslide. So all the debris which is moving with this landslide will enter eventually into this glacial lake, and this will lead to what? This will lead to swelling up of the water levels in this lake, which will then outflow. The barrier which was created by these moraines will be broken. Here you should understand this with the analogy of the dam. So just imagine a dam. What is the role of dam? So dam basically holds the water in the reservoir. If because of some reasons, because of some factor, the volume of that reservoir is continuously increasing, and the dam, that is the obstructing structure, if that structure is not able to withhold that increasing force, eventually the dam will break and all the water from the reservoir will flow downstream and it will lead to floods. Same thing is happening over here. Here also, till the point these moraines, this obstruction is able to control the river water, this glacial water, till then it's fine. But when the river volume will start increasing, it will breach these walls and the water will flow out. So here you can see that here the walls are breached and the water is moving out of this glacier. Now because the lake overflows, the walls are breached and the lake is overflowing. So all the water which was there in this particular lake will move downstream through these particular areas. Okay, so because the lake has experienced bursting, we say that glacial lake outburst floods. Okay, so we have glacial lake. The lake was formed because of the glacier. It underwent bursting, leading to the floods in the downstream areas. Okay, so this is GLOF. So for this to understand, we should understand the local factors, that what are the causes of the glacial lake outburst flood. Okay. So one is the glacial melt. Because whenever the glacial melting will take place, what will happen? The volume of this will increase, because till the point it was frozen, the volume was relatively less. As soon as the melting starts, the water from this glacier in the upstream areas will also further come down and will enter into this particular lake. So that is how the volume will increase in these lakes, right? Second thing is the earthquakes. So let us imagine that in the upstream areas there is some earthquake, or let us imagine that the portion, the land area on which this lake was created, that land area went under, experienced an earthquake, and because of that earthquake, this lake got disturbed. The morphology got disturbed. So that is also how the glacial lake outburst flood can be there. Fine. The third one is the landslides. Again, we have discussed that if there are landslides in the upstream areas, so all of the debris with the landslides will enter into the lake, which will increase the volume of the water, the levels will increase and will lead to glacial lake outburst flood. Then we have avalanche. The same logic applies for the avalanche also. Cloudburst. So let's say in the upstream areas there was a cloudburst. Again, cloudburst is what? It is the intense rainfall which happens over a very small area, local area. So that intense rainfall, the water of that intense rainfall will enter into this particular lake and will increase the volume. And similarly, the slope destabilization. So these are the causes which can lead to the outburst of this glacial lake and causing the floods in the downstream areas. Okay, so this is the phenomena of glacial lake outburst flood. The second important thing from the examination's point of view is that what are the NDMA guidelines for this? So NDMA says that first of all, as we all know that when it comes to disaster management, the first and the foremost thing is the identification of the potential sites where a disaster can take place. Okay, so there should be hazard zonation of various disasters. So that is the first thing, that identify the potentially dangerous lakes. First, identify that which are the areas prone to such phenomena. Second thing is, once you have identified the glacial lake outburst flood, and we know that a lot of water is flowing through this channel, so can't we uh, channelize these floods? By channelizing of the floods, we mean, so let's say these are the two areas in which all the water of this lake is moving in the downstream areas. So can we construct, let's say, another channel in between and connect these channels with this particular channel, so that some amount of water can be transferred to this particular channel, so that there is no one particular area which experience very high amount of water flow. Okay, this will lead to what? This will lead to diversion of the water in different areas, and that is how we can control the floods and the impact of it in the downstream areas on the humans lives and property. Are you getting it? So that is the thing. NDMA says that we can go for the flood channelization also. Flood channelization, that we will artificially channel these floods into different areas so as to divert the excess amount of water. Then we have multi-hazard early warning system. We all know EWS, that is early warning system, is very important. But here, multi-hazard early warning system is there. Why? Because we have seen that how the cascading impact of all these disasters are taking place. Okay, so just imagine in the upstream areas, there was a cloudburst which increased the rain. Cloudburst, disaster number 1. That cloudburst led to the flooding in the rivers which were coming down. Disaster number 2, floods. This cloudburst can also lead to generation of landslides. Disaster number 3. This flood and landslides, all the debris of this overflowing rivers and the landslide can enter into glacial lake, which then will be breached. That is GLOF. Disaster number 4. That is the point, that how all the one particular disaster can lead to other disasters as well. Landslide, avalanche, cloudburst, floods, glacial lake outburst, all these things are linked. So that is why we need to have an early warning system which can give warning signs for all the hazards. That is multi-hazard EWS. Only then a better planning can take place, better rescue operations can take place, right? Then obviously construction and building codes should be revised, because the climate changing is taking place. Climate is changing very fast. The morphology of the rock structures are changing fast. The slopes are getting destabilized. Human interference have increased, which is leading to land use change, deforestation. So basically the ecosystem is becoming very fragile. And because of this only, weather extremities are rising because of climate change. Because of all these changes in the frequency of the disasters, we need to regularly update the building bylaws and codes, and we need to implement them also, right? Then we have capacity building of NDRF, SDRF. So we need to focus on the capacity building. We need to provide them regular training, and not just this training in terms of manual skills, but training in terms of using technology also. Okay. And the last is the community participation. So communities skills should also be upgraded. If there are some traditional knowledge with the local communities living in those areas, those traditional knowledge can be integrated in order to manage the disasters, or how the losses can be reduced. Are you getting it? So these are the important NDMA guidelines for the glacial lake outburst flood. Fine. Okay. Next, moving to the next topic, that is loggerhead turtles. Okay. This has come in the context that a recent study was published in the journal which said that loggerhead turtles can learn and remember the magnetic signature of an area. So when they are moving on the earth, they have a special capability that they remember the magnetic signature of the earth, that what was the behavior of the geomagnetic field of the earth in this particular area. So whenever these loggerhead turtles roam, they migrate and they reach to a particular area, and as soon as they have this memory in action, that yes, this is the same area where I have been once, and with the help of this magnetic field of that particular area, they start dancing. So they feel happy that I have come again to the place where I belong. Okay, so basically this is a thing, that magnetic signature of an area and does a turtle dance when in a location that they associate with food. So this study is published in the journal. Okay, so obviously we are not going to study the turtle dance here, but again, from the examinations perspective, what we are going to study is certain key facts related to the loggerhead turtles, that what special characteristics this loggerhead turtle has. When it comes to India, so India has 5 species of turtles. Okay, so 5 species of sea turtles are found on the Indian coast. We have olive ridley turtles, we have green turtles, hawksbill turtle, loggerhead turtle, and leatherback turtle. All these 5 species are found on Indian coast. But when it comes to the nesting along the Indian coast, so except loggerhead turtle, the remaining 4 species nest along the Indian coast. Loggerhead does not nest along the Indian coast. However, when it comes to inhibition, so we have all the 5 turtle species on the Indian coast. Fine. So this is a picture of loggerhead turtle. Okay. So here you can see some of the chief characteristics of this turtle species. First thing is that this head of the turtle, okay, look at the size of the head of this loggerhead turtle. So head is there in the word. So this turtle species has the biggest head size compared to the other sea turtles, which can go up to 25 centimeters. So this has the biggest head. Fine. Second thing is, this turtle species also possess very big and strong jaws, right? They are carnivore species. So in order to feed them, they have very big and strong jaws. This turtle also has a very big size, not just the head, but the overall size. So in order to sustain that large size body, it had to eat a lot of things. And in order to eat more, it has to have a strong and big jaws, right? Then it has one claw in each front flipper. So these are the flippers, and these flippers of these turtles help them to swim in seas and oceans. So they can swim with the help of these flippers. So here it has one claw in each front flipper and 2 to 3 in the rear flippers. Okay, these front flippers are relatively smaller, but they are very thick, which help them to swim in fast moving sea waves also. Okay, when you will see the upper body of these turtles, so it has heart shaped brown reddish colored carapace, which live parasites and algae. So these are the small chief characteristics. The most important one is what? The size of the head and the size of the jaws. Fine. These are the two most important characteristics of these turtles. But then there is a basic question, that what is the difference between turtle and tortoise? Okay, so generally, sometimes we tend to use these words interchangeably, but they are entirely different features. Okay, so they have different features, they are different creatures. So here you can see these are the turtles, and here you have tortoise. From this image you can remember that these turtles are mainly in the marine environment, and the tortoise are mainly on the they are terrestrial beings, they are marine beings. Okay, so that is why it is written that it is aquatic and the marine form, and they are exclusively found on land. In coastal waters they can go up to some extent, but we are talking here about the dominant aspects. So here they are marine form and they are found exclusively on land. Tortoise. Okay, they are comparatively smaller in size because they have to swim, so they have comparatively smaller in size. Here see the size of these tortoise, they are larger in size. These turtles are in the sea, so obviously they will be eating fishes. Hence, some turtles are fish eaters, but they are on land, So they are herbivorous and feed entirely on the vegetation. Okay. If we have to talk about the head of turtles and tortoise, so they have unique ability that they can take back their head into their body. Okay. Turtles can also do this. They can take their head into their body. But the difference is their head is partially withdrawn into the shell, and their tortoise head can be completely withdrawn into the shell. Right? So you can have a look at the YouTube video also, that how turtles or tortoise withdraw their head into their shell. Okay. So you might see a tortoise without a head, but it should not be the case that head is not present over there. It might happen that a tortoise has just withdrawn its head into the shell. When you will move closer to the tortoise, it can allow its head to come out. Okay. Then coming to the turtles, they have thinner and more water dynamic shells, this upper body. So they are having thinner shells and they are water dynamic. Contrary to this, in tortoise, you are having rounded and domed feature shells. So here you can see a dome structure is there in the tortoise. So this is a dome-like structure, and this is a relatively water dynamic, a streamline structure is here in turtle, because they have to move into the water. That is their adaptation mechanism of the turtles and the tortoise in different types of environment, right? Then the turtles will have more flippers because they have to swim, so they will be having a lot of flippers like legs or webbed feet, right? But when it comes to tortoise, because tortoise has to move over a land, tortoise weight is larger, tortoise size is larger, so it will be having more legs, and these legs will also be bulky. See, these legs are bulky, and that is why it is said that tortoise has elephantine legs, because these legs are resembling the legs of elephants. Okay, so that is why tortoise have club like forelegs and elephantine hind legs, because it is often larger and heavier, and they have to move and they have to carry that extra weight with them. Okay, so now I guess that you understand the difference between the turtle and the tortoise, as well as their adaptability mechanisms in different environments. So because they are living in different types of environment, and hence they have different types of adaptation also. Okay, so now you can tell someone that turtles and tortoise are not same if the person does not know it. Yeah. Moving towards the next last topic, this is from the mains perspective. A recent study has been conducted, and the study has said that the stubble pollution, the stubble burning in Punjab and Haryana has nothing much to do with Delhi air pollution. So whenever Delhi experiences air pollution, we generally, the news articles are filled with this one perspective, that because of the agricultural field, the paddy fields which witness burning by the farmers in order to clear their fields in order to go for the rabi cultivation, so they just burn up their paddy fields, which is known as stubble burning. Because of this burning, when all the pollutants are released into the atmosphere, they move towards Delhi, and they are the dominant cause for the higher pollution in Delhi. This happens during winters. So, yes, a lot of articles do come, and yes, it is an issue. The thing is that this particular report has said that it is responsible only for the 14% of the PM 2.5, that is particulate matter 2.5, in Delhi NCR region. That means it is a small component of air pollution. Okay, fine. So this has been told by report. But again, when it comes to the examination, so how do we should how do how what things we should know, that which makes northern India, especially Delhi and other areas, as the hub of air pollution. Okay, so what are the unique factors which operate in northern India? For example, UPSC once asked the question that Delhi and Mumbai both are the large urban cities, both sustain huge population, both are having high amount of urbanization, concretization is there, land use change is there, right? Industrial emission is there, but still Delhi experiences larger pollution compared to Mumbai. What is the reason responsible for this? Because anthropogenic factors are almost similar, right? Almost similar, not identical, yes, but still. So that means there have to be some natural factors in the northern India which is making this particular region as vulnerable to air pollution. So in this session, we are going to discuss about those factors. Fine. Yeah. So first of all is we need to understand that the pollution in Delhi or the northern India generally increase when we are in winters. Okay. So during winters, air pollution becomes a larger problem. So what happens during winters? So first of all, understand that when we talk about, let's say, northern India, so this particular region is a mountainous area, and this is the region which becomes vulnerable to the pollution. Fine. So this plain area becomes vulnerable to pollution. So what happens over here? Now this northern India is far away from the moderating influence of the oceans. So we call this phenomena as a continentality, that this particular area, this land area is experiencing what? Continentality. So continentality means that it is far away from the moderating influence of the oceans and seas, and continental climate means that it will be having harsh climate, harsh winters, harsh summers. So during winters, because this plain, Gangetic plain, this entire plain area experience harsh winters. This harsh winters basically is known to create temperature inversion, right? So remember the basic concept of geography, that long winter nights is one of the favorable factor for creating temperature inversion. In temperature inversion, we understand that the temperature near to the Earth's surface is relatively low, and as you move up, the temperature increase. This is temperature inversion. Because the temperature of the air near to the Earth's surface in this particular area is relatively low, so that means what? The air is cold. If the air is cold, that means what? Atmospheric stability is there. If atmosphere is stable over there, relative high pressure is there, so winds will not move, right? So that means what? That this temperature inversion basically bring stability, stable conditions, and whatever pollutants are released into the atmosphere, they will remain stationary over that particular area. During summers, because the low pressure is created, thermal heating is there, air moves. So if the pollutants are released, those pollutants are dispersed away. Hence, you do not feel significant air pollution. But during winters, the pollutants are not dispersed, they remain stationary. So this becomes continentality, that is away from this ocean. Second related factor is the north westerly winds. So again, in this particular area, during winters, the wind pattern from the Central Asian region is like this. Okay. So winds in the northwestern and the northern portion of India enter from the Central Asia. And we all understand that Central Asia is colder than than India, right? Because it is in the higher latitudes also. So these northwesterly winds will further lead to what? They will further lead to temperature inversion. They will further lower down the temperature. Are you getting it? These northwesterly winds can also bring with them dust, because you have deserts in Pakistan, deserts in Afghanistan, and some deserts in the Central Asian region also. So they can bring dust with them, and that dust will enter over here. Are you getting it? Also, this particular area, if we are saying that Punjab, Haryana are having stubble burning issues, so the winds will take those pollutants towards Delhi and the entire Gangetic Plains, because the winds are moving in this direction. So it will be spreaded into this particular area, right? The third thing is the presence of Thar desert also, because The dust from this Thar desert is also spreaded into different areas and can lead to air pollution. Next factor is the presence of Himalayas. Okay. So here, because you are having now Himalayas, so these Himalayas do what? They also trap the pollutants which are there in this Gangetic plains. Okay. So Himalayas do trap the pollutants and they do not allow them again to disperse. The next factor is the basin topography. Okay. So this entire plain area, this northern plain area is having a low-lying basin topography. So it is somewhat like this. So what happens that when the pollutants enter into this topography, relatively they remain stationary over this topography. And hence the pollutants relative to other areas of the world, they remain stationary over this particular area. And these issues are not only related to India. In totality, the entire South Asian region experience higher air pollution compared to other parts of the world. Why? Because we have such specific type of physiography and climate here. Are you getting it? So these are some of the natural causes which make this particular area more vulnerable to air pollution. It get intensified because of the anthropogenic activities. So there are industrial emissions, there are vehicular emissions, we have the issue of stubble burning, we have the issue of waste mismanagement, we have the issue of concretization and unplanned urbanization, issues of land use changes, we are going for deforestation, we are encroaching the wetlands which generally are the carbon sinks, they are the natural filters. Okay, so because of these anthropogenic activities as well as these natural causes, the North India suffocates, and that too primarily in winters. So stubble burning, yes, is a factor. Now what is their percentage? That's a different thing. That 14%, just the 14% as per the recent study, the context in which we are discussing this particular article today, right? This problem becomes this why this is so relevant, that not just the economy, not just the infrastructure, not just the environment as a whole, this air pollution has a direct impact on the human health and up to a very large scale. So here you can see that the air pollution virtually impacts almost every part of the body. So it impacts lungs, it impacts the bloods, it impacts vascular system, it impacts brain, heart, reproduction. So whenever PM 2.5, if it is able to particulate matter, basically 2.5 or 10 depending on their characteristic, if they are able to enter your body, some through bloodstream or some through inhaling, so they can lead to the dangerous impacts on almost everything of your body. That is why it becomes so much important. And here, not just the human health, think about the health of the other species, those species which cannot talk about the issues of air pollution, those who do not have the liberty. Turtles will not talk about air pollution, neither the tortoise, nor the tigers, nor the birds. It is we who are discussing this thing in the lecture, na? Right? So the thing is that the impact of the air pollution is multifold. Trees will feel their impact, wetlands will feel its impact, economy will also feel its impact. Okay, industries will feel their impact, agriculture is going to feel its impact, the farmers income is going to feel their impact. So when we talk about air pollution and we think about its multiple impacts, do not restrict your imagination only to the human health. Fine. In this relation, if you ask that, if you think that what can be the steps or what can be a way ahead, which can be taken in order to combat air pollution, right? So yes, we can think about graded response action plan, national clean air program. So we have such programs. We have GRAP, we have NCAP, graded response action plan, national clean air program. Okay, then we have institutional bodies like Central Pollution Control Board, CPCB, SPCBs, etc., which also talk about pollution, which talk about waste management and all those things. Again, my point is, these are the things which we already are having. So obviously, one thing is that we need to implement them in a better way, right? But then we need to look at the underlying factors of it. We cannot change our physiography, we cannot change our climate, we cannot dislocate Himalayas, or we cannot stop the northwesterly winds coming into India. Natural factors will remain there. Only the human factors can be taken care of. So how can be taken they can be taken care of? One, public transportation should be enhanced, it should be increased, public transportation, so that per unit vehicular emission goes down. Second, planned urbanization has to be there. So urban areas should have green spaces, they should have blue spaces. The traffic lanes, the roads are designed in such a manner that the commutation time is reduced. Because when the commutation time gets reduced, so obviously the emissions will also get reduced, right? So for this, we generally have grid pattern roads. So grid pattern roads is one of the solution through which the per unit emission can reduce, because commutation time is reduced, because grid pattern basically facilitates the diversion of the traffic at certain small intervals. Okay, so there is no traffic congestion in one particular road. If there is a congestion, so obviously the vehicles will remain stationary and they will lead to emission of the pollutants. Third thing is that agriculture and industries need to be taken care of. We have seen that how waste can also lead to air pollution, waste mismanagement. So in Delhi, you will find a lot of landfills virtually having height more than some of the important plateaus and mountains in India. So those high landfills also lead to air pollution. So we have to go towards proper solid waste management, and all the smaller waste management like plastic management, e-waste management, and all those things, right? We need to go for them. Similarly, we need to take care of our water bodies and water systems, where you can talk about NK Sink panel recommendations. So these are some of the strategies in the long run which our policy makers should take into account while controlling the air pollution or devising a strategy for the air pollution. Okay, so this was all from my side for today's session. I hope you have liked it. If yes, then let us know. Do like the video, share it with your friends. Thank you everyone. All the very best.